All right, kids, we're in the home stretch of Chapter 9, last section, and it might be the fastest lecture that we have for this, I don't want to say for the year, but definitely for the chapter. We are going to compare linear, exponential, and quadratic models. You are very familiar with two of those. You are not familiar with one of them yet. So you know linear and quadratic. We have yet to hit exponential today. You're just going to get kind of a just super brief glance at it. We're going to look at it into more detail later. And so we're going to look at equations, what they look like, and characterize them so that you can tell either by the graph or by the equation what sort of model it is. So in the past, you have learned and done slope-intercept form, which is y equals mx plus b. If I were to graph this equation, this is what it would look like. And it makes a line. And we call this linear. Or we say linear, just to be funny. We're not serious. Hey, by the way, I forgot my disclaimer. Remember, these lessons are not the best lessons in the whole entire world. They're just to help you out if you need something, okay? If you have other more pressing questions or if you want a more thorough explanation, you know that you can come ask. Okay. We have also done equations that look like this. This is called a quadratic equation. You know this. It has a square there, and it's going to make a parabola. Some are skinny, some are fat, some open up, some open down. And the model, it's a little redundant, but it's a quadratic model. Okay, this here is called growth and decay. You see this a lot with money, for example, calculating interest or the value of something. And when it is graphed, it shows a curve. It's not two-sided like a parabola, where it will have a gradual increase and then a sharp increase, or a gradual decrease and then a sharp decrease. So this is a curve. And it's called an exponential model. So if you'll imagine, so say if you have a credit card that goes unpaid, right? And then you have to pay interest on that balance. Well, there's going to be a little bit of a fee. Well, if you go to the next month and you don't make any changes, then you're going to have an even greater balance. And a greater balance, and you have to pay even a greater fee. I'm kind of tripping over my words here. And it perpetuates, right? If it goes unpaid, it's going to have an exponential growth. It's going to be an exponentially bad situation there. And so that's the sort of situation that this is representing. So I always think that these last sections of the chapters are kind of just, I don't know, a little extra. I mean, it's good stuff. But that's all there is to it. I guess it's simple. I'm not going to apologize for simple, but this is a short lesson. All right, this is your homework. You will need a coordinate plane for it. For each section, you'll need to tell me two things. Is it linear, exponential, or quadratic? And then also, is it a line, a curve, or a parabola? So I'm not looking for the form of the equation, so don't tell me, for example, that these are growth and decay, because the model is exponential, and this lesson is on the model, right? Not the format of the equation. Okay, let's look at here. No, so I kind of gave those away. If the exponent is an x, well, that is typically going to be exponential. But if it has an x squared in it, that's going to be a quadratic. And if there's no exponent, then you know that that's going to be linear. It'll make a line. I'll warn you, number 4 is kind of tricky. Don't overthink it. Maybe consider a distributive property in there. Okay, for 7 through 12, you will need to graph those on a coordinate plane. Here's your coordinate plane. Make sure you number them clearly. Just be aware that every so often you will have coordinates that go off the plane a little bit. Also, here are some fractions. You can just estimate. And once you graph them, then you can tell me again if it is linear, exponential, or quadratic, because it makes a line, a curve, or a parabola. So 2 answers for each of these questions. So good luck with that. Yeah, and if you have any other questions, please contact me at drones@d231.rochelle.net. All right, thanks a lot, kids. Wow, short lesson, 6 minutes. Hope it was a good investment for you. Thanks.